Right, this is Zachary Vallon, Chase Vallon, and Brandon Blaisdell, and this is page 414, activity shearing stresses and beams, and we're going to do 4 experiments. Each one is with playing cards as our material and batteries as our supports. We're supposed to analyze how it deflects and what the stresses might look like or shear might look like in the beam. So for the first experiment, we took a 3.5 by 1 inch playing card, and we're going to put quarters on it and see what it looks like. So you can see that the beam deflected quite a bit, and that's due because the card can't hold that much weight, so it just ends up going towards the table. And now it's going to hold 5 playing cards just loosely stacked on top of each other, and we're going to see now how it deflects with a similar or the same amount of weight. So you can see that it deflects not as much, but it still deflects, and this is because the cards are sliding past one each other because the friction in between the cards is pretty low. Alright, now for the second one, we have a card that's stapled, still 3.5 by 1 inches. There's 4 staples in it, and this is going to create more of a uniform beam, but it's still, the cards have a little bit of room to slide in between each other, so the beam is still going to deflect a little bit. So this is what it looks like whenever you put 15 quarters, the same amount as the first one on it. So you can see that it's deflecting. The top of the beam is in compression, so that's also what is causing the shear in the beam. If you add a larger force, that it would increase the shearing force in this. So now we're going to go to the third one, and there is one beam here, still 3.5 by 1 inches, and it's glued together with rubber cement. This is creating one whole uniform beam, and this is going to basically show that the beam isn't going to deflect very little, and so this is the best type of beam to use whenever you're creating stuff, in our case. And so here it is, 15 quarters. This would be able to withstand a large amount of force or a large amount of shear force due to all the playing cards glued together. Acts as one uniform unit or one uniform beam in this case, and it's allowed to resist horizontal shearing forces. That's from the glue. It would take a lot of laminar flow to separate this, and this can also be seen on page 417 in figure 8-3, and you can see examples A, B, C, and D of the cards loosely stacked, the cards stapled, and the cards glued together. And as you can see in our case, the glued beam is the most rigid beam. That's from the shear in it. Very large. It can withstand a larger weight. Strips are not allowed to slide compared to the first example, when the only horizontal forces in the beam were the friction forces themselves. And on playing cards, the friction force would be really low because they're sliding.
From this experiment, I learned that when you make the cards more uniformly joined together, it makes it stronger and it can handle a bigger load. Also, I learned that the surface of the material you're using, such as playing cards with the friction being so low, it does make it very unstable and makes it very hard to work with.
Alright, in this lab I learned that even though it's the same weight across all of them, the beams do deflect differently, and this is because how they're joined. I'd say this lab's pretty beneficial in showing you firsthand what it looks like. In this lab I learned that even though we're using the same material, the same weight, and in this experiment the same thickness of cards, the joining process of how you join them and where you join them with staples or glue really affects how the material can withstand horizontal forces and shearing stresses within the beam. And that the way the material is joined, the shearing force in them will either increase or decrease depending on how it's joined and what it's joined with. And this lab was really beneficial in showing how the different forces act even though it's using the same material throughout.
Also, had we changed the location of the supports, it would have helped the material not deform as much if we had moved the supports inward rather than keeping them out towards the ends.